The mystery of the Bermuda Triangle. In early December 1945, 5 military aircraft launched from a Florida airbase for a routine training mission, venturing into the Bermuda Triangle, a stretch of the Atlantic Ocean. This area had already become known for a troubling pattern of disappearances of planes and ships during the 1940s, puzzling investigators who struggled to pinpoint a cause. The mission, dubbed a standard exercise, was led by an experienced pilot with extensive flight hours. The plan was straightforward: fly eastward to drop training ordnance over a designated coral reef, then proceed north past a nearby island, and finally turn westward to return to base. Weather reports predicted mostly clear skies with a minor chance of scattered showers, suggesting a smooth operation as the 5 planes departed. Initially, everything proceeded as expected. The squadron completed their target practice over the reef and began their northward leg toward the island. However, around 3:45 p.m., an hour and 45 minutes into the flight, trouble emerged. The lead pilot radioed the base, his voice laced with confusion, reporting that land, expected to be the island, was nowhere in sight. He expressed concern that the group had strayed far off course. The base responded, asking for their position, but met with silence. Ground crews expecting to spot the aircraft on the horizon given the clear conditions and proximity to shore, scanned the sky in vain. After a tense pause, the pilot radioed again, admitting uncertainty about their location and the absence of visible landmarks. Attempts to communicate back were met with static for 10 minutes, until another crew member contacted the tower, sounding distressed. He described a disorienting scene where even the ocean appeared unfamiliar, and navigation seemed impossible. Communication faltered further as the lead pilot relinquished command to another crew member for reasons unclear. Another voice soon broke through, panicked, estimating they might be 225 miles northeast of the base, rambling about entering white water and being utterly lost. Recognizing the gravity, the base dispatched a rescue aircraft to the last known position. Tragically, 10 minutes after takeoff, the rescue planes also lost contact with the tower. Within half an hour, 6 aircraft, 5 from the original mission, and 2 rescuers had vanished over the Atlantic east of Florida. A massive search ensued, covering over 250,000 square miles of ocean, but no trace of the 27 men aboard was ever found. Investigations later suggested navigational issues plagued the mission. The lead pilot mistakenly believed they were over the Florida Keys, intending a northeast turn to reach the mainland, unaware they were actually near the intended island, which resembles the Keys from above. Compass malfunctions, a recurring problem in the region, likely contributed. Other crew members disputed the course, leading to conflicting decisions that sent the planes farther out to sea. Eventually, fuel depletion likely caused a crash north of a coastal island. The rescue plane's fate may have involved a known fuel issue, with witnesses reporting a distant explosion, possibly from a leak. The Bermuda Triangle-esque compass anomalies are attributed to an underwater volcano that formed Bermuda millions of years ago, leaving basalt rich in magnetite, a highly magnetic mineral. Estimates suggest 500 billion tons of magnetite in the area can skew compasses by up to 10 degrees, affecting a wide region detected 200 miles from Bermuda. Another theory involves methane blowouts, where gas erupting from the seafloor could destabilize vessels or aircraft. A 1948 passenger flight, flying low to avoid winds, disappeared after a routine check-in, with no distress call. Some speculate a methane release ignited its engines, though this is more likely to sink ships via foamy water than affect planes. Alternatively, the pilot may have misjudged altitude, descending into the ocean unnoticed. Another 1948 disappearance involved a passenger plane that landed briefly in the Caribbean to address a weak battery and faulty radio transmitter. Despite repairs, the plane took off late, circling to establish two-way communication before heading northwest. An hour into the flight, its position was confirmed, but later signals were erratic, picked up by a distant airport instead of the intended one. The plane never arrived, and an extensive search yielded no clues. Battery failure might have crippled navigation, leading to a fuel exhaustion crash over the dark ocean. Many attribute these losses to the region's frequent hurricanes and storms, fueled by warm, moist air from the Atlantic, meeting dry Sahara winds, intensifying over thousands of miles. As they reach the Triangle, these storms can overwhelm aircraft, especially in the pre-GPS era. Estimates suggest 50 to 100 planes have vanished here in the past century, often in unverified incidents. With rising sea levels and warming oceans, the Triangle's dynamics may evolve, adding new layers to its enigma. 10 strange lunar mysteries. Solar bombardment affects unlike Earth. The moon lacks a magnetic field or atmosphere to shield it from the sun's radiation. During solar storms, the lunar surface, even in shadowed polar craters, experiences intense energy. Recent studies using orbital instruments reveal that this radiation can charge the soil, causing electrostatic sparking in frigid regions, potentially breaking down the surface and posing risks for future lunar bases near water ice deposits. Magnetic traces in lunar rock samples from lunar missions show a puzzling discrepancy. Some rocks formed in a magnetic field as strong as Earth, while others show no magnetic exposure. The moon's small size shouldn't support such a field, but one theory suggests that cooling metals like titanium interacted with a molten core, intermittently activating a dynamo. This could explain the variation, though the strength of the field remains debated. Enigmatic lunar swirls across the moon's surface. High reflectivity swirls contrast with darker areas, often overlaying craters. These patterns are linked to magnetic anomalies, possibly from ancient lava tubes magnetized during cooling. Theories include cometary impacts scouring the surface, or solar wind interactions preserving bright material, but the swirl's inconsistent presence near anomalies keeps their origins a mystery. Hidden lava tubes. Lunar lava tubes, formed by ancient volcanic flows, could be ideal for human colonies, offering protection from radiation and temperature extremes. Some are vast enough to house entire cities, with heights rivaling Earth's tallest structures, yet their full extent is unknown. Many remain hidden without surface collapses, making them potential sites for future exploration or even alien artifacts. Ancient volcanic atmosphere. Billions of years ago, volcanic activity may have given the moon a temporary atmosphere. During its peak, 3 to 4 billion years ago, volcanic gases could have accumulated faster than they escaped, lasting up to 70 million years. If true, trapped volatiles in polar regions could be a resource for future missions, though evidence is still emerging. Transient lunar clouds. Over centuries, observers have reported reddish clouds over lunar craters, possibly from volcanic outgassing kicking up dust. These sightings, often by credible astronomers, lack consistent photographic evidence, raising questions about whether they're lunar phenomena or distortions from Earth's atmosphere. The mystery persists due to their fleeting nature. Recent volcanic activity. Lunar volcanism was thought to have ceased 3 billion years ago, but newer samples suggest activity as recent as 2 million years ago. This late volcanism, possibly driven by radioactive decay concentrated on the near side, hints at lingering magma beneath the surface, challenging assumptions about the moon's geological dormancy. Massive buried anomaly. Beneath a vast impact crater on the moon's far side lies a gravitational anomaly, a dense mass weighing 2.4 quadrillion tons, spanning an area 5 times the size of a large Earth island, likely the core of the impacting asteroid. Its depth, hundreds of miles below the surface, raises questions about alternative origins. Levitating dust at dawn. At the moon's terminator, the day-night boundary electric fields from charged soil cause dust to levitate, creating a glowing crescent visible from space. Observed by astronauts and spacecraft, this phenomenon could affect long-term lunar missions, as the fine dust and electric fields may pose challenges to equipment and habitats. Flashing lunar lights. For centuries, reports of lights on the moon have intrigued observers. From medieval monks noting fiery glows to modern astronomers detecting bright flashes, some, like gaseous emissions seen through suggest outgassing, while others near specific craters hint at ongoing activity. These transient phenomena, often tied to ancient volcanic regions, remain unexplained. The moon continues to captivate with its blend of familiarity and strangeness, revealing mysteries that deepen our curiosity about the cosmos. What other secrets might our closest neighbor hold? 25 unsettling space facts. Galactic collisions. Galaxies sometimes merge in a process akin to cosmic consumption, where larger ones absorb smaller neighbors. In roughly 4 billion years, our galaxy may collide with a nearby one, potentially disrupting all life within it. Silent, void-like movie portrayals. Space lacks sound due to the absence of particles for vibrations to travel through. Only dense gas clouds might carry faint noise, but the overwhelming silence could be maddening in the vacuum. Wandering planets. Some planets break free from their stars, hurtling through space at speeds up to 30 million miles per hour. These massive rogues, potentially larger than Jupiter, could one day threaten Earth with catastrophic impact. Shedding skin in orbit. After weeks in space, astronauts' calluses and dead skin can flake off, especially from their feet, creating floating debris in zero-gravity and unsettling reality for hygiene-conscious travelers. Colossal exoplanet, largest known planet, a gas giant far beyond our solar system, is nearly 30 times Jupiter's mass. Its size blurs the line between planet and failed star, challenging our classifications. Blazing supernova 1. Stars explode. They release immense energy. One recorded supernova reached temperatures 100 billion times hotter than Earth's average and shone brighter than any other observed. A cosmic spectacle of destruction. Frozen remains in orbitally space missions sent animals and some humans into the void. Without oxygen, their bodies don't decay, leaving preserved relics among the debris circling our planet. Mysterious white holes, theoretical opposites of black holes. White holes might exist, repelling all matter and light. Some speculate every galaxy's central black hole could be linked to one, emitting energy from an unseen source. Black hole, fate falling into a black hole could split your reality. One theory suggests you'd be stretched into oblivion instantly, while another posits you'd survive unharmed in a warped timeline. Neither outcome is inviting. Cosmic collapseth universe might end in a big crunch, shrinking back to its origins, or a big rip, where expansion tears everything apart, atom by atom. Both scenarios spell doom for existence as we know it. Unexplained galactic drifter phenomenon dubbed dark flow pulls entire galaxy clusters toward an unknown destination. Scientists remain baffled by what's driving this mysterious cosmic migration. Sudden meteors. Their unpredictability underscores the vulnerability of our planet to random celestial bombardment. Drifting mooniarch year. The moon moves a few centimeters farther from Earth. Over eons, this could disrupt tides, water levels, and even slow our planet's rotation. Hostile neighbor, Planeta, nearby planet, hotter than 500 degrees Celsius, endures crushing atmospheric pressure and acid rain, making it an inhospitable world we're unlikely to visit, even with advanced technology. Solar system's end when our sun exhausts its fuel, it will swell into a red giant, engulfing nearby planets and obliterating our solar system. Fiery finale billions of years away. Space's deadly vacuum without a spacesuit. You'd survive mere seconds in space before losing consciousness from oxygen deprivation. Holding your breath could rupture your lungs instantly. Scorching exoplanetone. Distant planet's surface rivals our sun's heat, reaching thousands of degrees due to its tight orbit around a blazing star, earning it a reputation as an infernal world. Freezing cosmic average spaces, average temperature hovers near absolute zero, around minus 270 degrees Celsius. This bone-chilling cold makes survival without protection impossible across the universe's vast reaches. Fading night sky in trillions of years. The night sky could go dark forever as stars burn out and galaxies drift beyond view, leaving future observers in an empty starless void. Elusive extraterrestrialities, countless stars and planets. We may never contact alien life. Galaxies' rapid separation could make intergalactic travel impossible without faster-than-light technology. Solar storms 3. Massive solar flares, expected roughly every century, could disrupt satellites and aviation systems. The last major event struck over 150 years ago, meaning we're overdue. Space travel risks safe. Hundreds who ventured into space, several never returned, making it a perilous journey. Though safer today, the frontier remains fraught with danger. Invisible universe have observed less than 5% of the universe's matter. The rest dark matter and energy remains unseen and poorly understood, shrouding most of existence in mystery. Rogue black holes, untethered from stars, roam our galaxy at millions of miles per hour. One, the size of a large planet could spell disaster if it crosses our path. Quasars, immense power found at active galaxies' cores. Quasars unleash energy thousands of times greater than our entire galaxy, making them the universe's most dazzling and formidable objects. These facts reveal a universe both awe-inspiring and terrifying, where beauty and danger coexist on an unimaginable scale. Stay curious, but brace for the cosmic unknown. Lunar mysteries unveiled, the moon's hidden side. When you gaze at the moon, you always see the same face, whether it's a crescent or full. This is because the moon is tidally locked with Earth, spinning on its axis at the same rate it orbits it. The far side, often misnamed the dark side, isn't perpetually dark. It receives sunlight just like the near side. However, its invisibility from Earth makes it a communication dead zone for spacecraft. As the moon blocks signals, Drifting away slowly, the moon is gradually moving farther from Earth, inching away at about 4 centimeters per year due to gravitational interplay. Earth's stronger pull slows its own rotation, while the moon's tug stretches its orbit. Over eons, this drift could disrupt ocean tides and currents, though significant effects are far in the future. A celestial memorial, the moon, hosts a unique tribute. The ashes of a renowned scientist were carried aboard a lunar probe in the late 1990s. When the probe impacted the surface, it scattered those remains, symbolically burying them on the lunar landscape, a poetic honor for a space enthusiast. Extreme temperature swings. The moon's surface endures wild temperature shifts. At its equator, daytime highs can reach 260 degrees Fahrenheit, while nights plummet to minus 280 degrees Fahrenheit. During an eclipse, the surface can drop 500 degrees Fahrenheit in just 90 minutes. A stark contrast to Earth's more stable climate, necessitating specialized gear for explorers. Earthly origins theory, one leading hypothesis, suggests the moon formed from Earth itself. Billions of years ago, a massive impact may have ejected a chunk of Earth into orbit, which coalesced into the moon. Lunar rocks share oxygen isotopes with Earth's, supporting this idea, though questions about the moon's spherical shape linger. Lunar water cycle ice exists on the moon, particularly in shadowed craters. As temperatures rise, this ice can melt into vapor, travel across the surface, and refreeze elsewhere. This unique cycle, observed in detail since 2009, could provide water or even fuel for future lunar missions. Lunar-inspired superstitions for centuries, full moons have been linked to unusual behavior, with medieval tales attributing mental quirks to its glow. The term lunatic stems from this belief, though modern science finds no clear link. Still, some track events like births or accidents during full moons for patterns. Supermoon effects, when the moon's orbit brings it closest to Earth. It's called this proximity amplifies tidal forces, sometimes causing unpredictable ocean current. Fishermen have reported chaotic seas during these events, underscoring the moon's tangible influence. Moonquakes. The moon experiences seismic tremors, dubbed moonquakes, often triggered by Earth's gravitational pull. Unlike brief earthquakes, these can last over 30 minutes, though they're milder, highlighting the moon's dynamic nature. Lunar litter. Human missions have left behind equipment, rovers, and even flags on the moon to lighten spacecraft for return trips. These remnants, alongside scientific instruments like reflectors, form a scattered archive of our visits. Sharp shadows, without an atmosphere to diffuse light. Lunar shadows are pitch black and sharply defined, unlike Earth's softer edges. This stark contrast creates an alien visual landscape for astronauts. Hazardous moon dust. Lunar soil is razor sharp due to the lack of weathering, posing risks to equipment and health. During one mission, inhaled dust caused severe irritation, revealing its potential to harm lungs or brain cells. Cold War lunar plans. In the 1950s, during heightened global tensions, one nation reportedly considered detonating a nuclear device on the moon as a display of power. Though likely a thought experiment, the idea underscores the era's extreme ambitions. Mysterious flashes, bright, fleeting lights on the moon, observed for centuries, remain unexplained, likely caused by meteorite impacts. Some flashes defy this explanation, with theories pointing to electrical discharges in the thin lunar atmosphere. Tenuous exosphere. The moon has an ultra-thin exosphere of charged particles, shaped by solar winds. Studied by a 2013 mission, it offers insights into space interactions and could guide future lunar exploration. Ancient volcanism. The moon was once volcanically active, with lava flows shaping its surface billions of years ago. Evidence like volcanic deposits and gas traces in rocks suggests activity persisted longer than thought. No magnetic shield. Unlike Earth, the moon lacks a magnetic field, leaving its surface exposed to solar radiation. It resides within Earth's magnetic tail, but this offers little protection, affecting surface erosion and atmosphere retention. Helium-3 potential. The moon's surface holds helium-3, a rare isotope ideal for clean nuclear fusion. Deposited by solar winds, its extraction could power future energy needs, though the technology remains undeveloped. Thermal shocks. During the lunar night, lasting 14 Earth days, temperatures dropped to 173 grados bajo cero, only to soar above 100 degrees Celsius by day. Rapid shifts in shadowed areas can crack the surface, mimicking tidal waves. Meteor swarms. The moon faces constant meteoroid impacts, sometimes in dense swarms traveling together. These barrages scar the surface and offer clues about solar system dynamics. Aiding mission, safety planning, lunar pits. Collapsed lava tubes form flat, rimless craters called pits. Discovered in 2009, these could shelter future astronauts from radiation and extreme temperatures, while revealing the Moon's volcanic past. Moon rocks on Earth since 1969. Missions have returned over 380 kilograms of lunar material. Additionally, meteorites from the moon, blasted off by impacts, have landed on Earth, providing a cost-free way to study its composition. Earth-like glow when Earth reflects sunlight onto the moon during its new phase. It creates a faint Earth glow. This subtle light helps scientists measure lunar reflectivity and aids astronaut navigation. Dusty tail: the moon trails a faint dust cloud along its orbit, lifted by solar radiation. This elusive tail could affect surface chemistry and pose challenges for equipment in future missions. Unique scent: lunar soil, exposed to cosmic rays, releases a burnt gunpowder-like smell when brought into Earth's atmosphere. This surprising trait, noted by astronauts, adds to the moon's enigma. The moon remains a source of wonder, blending beauty with mysteries that continue to unfold. From its geological quirks to its influence on Earth, it's a testament to the universe's complexity. And now, something even darker awaits: 25 disturbing real-world facts. Probably didn't know. 1. Microplastics in your body every week. Humans unknowingly consume tiny plastic particles roughly the weight of a credit card through food, air, and water. Bottled water may even contain more microplastics than tap. The long-term health effects, still uncertain. And alarming, too. The cost of getting sick in some countries, millions fall into debt just to cover medical care. For many, that includes paying for a loved one's treatment, revealing how broken some healthcare systems really are. 3. Twisted childhood indoctrination. Notorious extremist group in the early 1900s specifically targeted children and teens with propaganda, embedding hateful ideas from a young age. A chilling reminder that manipulation can start early. 4. Fridge doors designed by tragedy. Magnetic fridge seals were born from tragedy. In the past, kids got trapped and suffocated inside latching fridges, which led to new laws requiring internal release doors, a change that saved lives. 5. The danger of human bite. A human bite might not seem scary, but it can lead to serious infections, especially on the face or hands. Even a small break in the skin can turn dangerous fast. 6. Nature's real-life zombie creatures. Some fungi can infect insects, hijack their nervous systems, and control them to spread spores, turning them into real-life zombies. It's creepy, and it's happening out there. 7. Bugs in your coffee. Regulations allow up to 10% of coffee beans to contain insect fragments. So that morning cup of joe, it might have a little extra protein you didn't ask for. 8. Unnecessary medical exams. Many pelvic exams performed on young women may not be medically necessary. They can cause stress, cost money, and offer no real benefit, especially in areas with limited healthcare. 9. Shadow profiles on social media. Even if you've never made a Facebook or TikTok account, data about you may still be collected from your friends' activity. Platforms build ghost profiles behind your back and you wouldn't even know it. 10. A spinning birth machine in the 1960s. Someone actually patented a machine that spun mothers around to speed up childbirth. It was never widely used, but it's one of the weirdest medical ideas ever recorded. 11. Tooth eye surgery in extreme cases. Doctors can use a patient's own tooth shaped and fitted with a lens to restore sight by implanting it into a damaged eye. Sounds like sci-fi, but it's real. 12. Supersized spiders thanks to warming temperatures. Spiders in some places are growing bigger and more active. As predators, they can unbalance ecosystems and speed up organic decay, which releases more greenhouse gases. 13. A chilling Titanic prediction. A novel written in the 1800s told of an unsinkable ship that hit an iceberg and sank due to a lack of lifeboats. The real Titanic disaster happened 14 years later. 14. Virtual invisibility. Experiments in virtual reality show the brain can be tricked into feeling like it's invisible just by simulating touch on a blank space. Our sense of self is more fragile than we think. 15. The truth behind body odor. It's not your sweat that stinks. It's the bacteria on your skin breaking that sweat down. The science isn't fully understood yet, which is why we're stuck relying on the 16 lost security codes. Persistent rumors claim that critical launch codes were once lost for months. While never confirmed, the idea alone has kept people up at night. 17. Bloody cures of the past in the 1600s. Some believe that drinking or applying blood from executed prisoners could cure diseases like epilepsy. Thankfully, science moved on, but not before some truly grim practices. 18 tumors that grow teeth and eyes. Rare tumors can form in the eye socket and contain actual teeth, hair, or even eye-like structures. They're usually harmless, but creepy, and they can affect vision. 19. The cost of fake smiles. Faking a smile, especially at work, can backfire. Studies show it may cause emotional strain, lower your mood, and even lead to social withdrawal. 20. No safe seat on a plane. Despite urban myths, there is no single safest seat on a plane. Survival in a crash depends on multiple factors. That said, flying is still safer than most everyday activities. 21. Night owls and personality quirks. Studies suggest that people who stay up late may show higher levels of narcissism or manipulation. It doesn't mean they're dangerous, just an interesting psychological link. 22. Blood transfusion. Dangers. Receiving the wrong blood type can cause devastating immune reactions, leading to pain, organ failure, or worse. Even compatible transfusions can carry hidden infection risks. 23. Medical cover-up scandal in the 1980s. A pharmaceutical company knowingly sold blood products tainted with a deadly virus to developing nations after pulling them off the market elsewhere. Thousands were infected. 24. Baby cages hung from windows in the 1930s. Parents in crowded city apartments used metal cages hung outside windows to let babies get fresh air. Looking back, it's hard to believe it was ever considered safe. 25. Murders that stay unsolved in certain regions. About 1/3 of all murders are never solved. With cold cases stacking up, limited resources and silent witnesses mean many families never see justice. The hidden order of chaos. The universe operates in two fundamental ways. Where chance drives outcomes, and the deterministic, where rules govern predictability. In the probabilistic mode, tiny events like a butterfly's wing flap can cascade into massive, unpredictable consequences, such as a storm halfway across the globe. In contrast, the deterministic mode follows strict cause and effect, suggesting that with perfect knowledge of initial conditions, the future could be precisely forecast. How do these modes intertwine? And can something as small as a butterfly's flutter really influence a tornado? Chaos theory offers a lens to explore this, revealing connections between disorder and hidden patterns. The chaos game. Order from randomness. Consider a simple experiment. Draw 3 points on a sheet of paper to form a triangle. Label them A, B, and C, and mark a starting point inside. Roll a die to decide where to place the next dot between the starting point and a 4 or 1 or 2, B for a 3 or 4, and C for a 5 or 6. Repeat this process, always drawing the next dot halfway between the last point and the vertex indicated by the die roll. At first, the dots seem scattered, but after many iterations, a surprising pattern emerges. A Sierpinski triangle, a fractal of stunning symmetry. This demonstrates how apparent randomness, guided by simple rules, can yield intricate order, a hallmark of chaos theory. Deterministic chaos in numbers. Take a random decimal number, multiply it by 10, and remove the digit before the decimal point. Repeat this process. Multiply the result by 10, remove the leading digit, and continue. This deterministic rule should, in theory, allow precise predictions. However, after several steps around 15, on a typical computer the results become unpredictable. The process discards information with each step, and tiny differences in the initial number amplify over time, making long-term forecasts impossible. This sensitivity to initial conditions illustrates how deterministic systems can become chaotic. Chaos theory's broader implications. Chaos theory studies systems that are following clear rules yet are so sensitive to initial conditions that long-term predictions are impractical. It shows how interconnected everything is. A single-celled organism, a social movement, or an ecosystem all exhibit dynamic, deterministic, nonlinear behavior. These systems don't evolve predictably but are prone to rapid, transformative changes, often living on the edge of chaos. Traditional science assumes predictability in phenomena like gravity or chemical reactions, but chaos theory embraces the non-linear and unpredictable like weather, turbulence, or market fluctuations. It challenges the Enlightenment era belief in absolute scientific certainty, acknowledging that even with vast data, uncertainty persists due to small, compounding variables. Hidden patterns and fractals, chaotic systems often follow stable pathways, influenced by strange attractors that balance long-term stability with short-term unpredictability. These pathways reveal self-similar patterns, fractals seen in nature, from snowflakes to mountain ranges. Fractals, a concept pioneered in mathematics, describe irregular, repeating patterns across scales. A mountain range's jaggedness mirrors that of a single peak, showcasing consistent irregularity. This fractal geometry helps model complex natural systems, like tree branching or fluid turbulence, capturing the beauty of chaos. The butterfly effect in feedback loops. The butterfly effect highlights how minute changes can lead to vast outcome. In weather systems, a small temperature shift can alter atmospheric patterns, making long-range forecasts elusive. Feedback loops amplify this chaos. In the stock market, a price rise prompts buying, which further drives the price up, creating unpredictable cycles. Similarly, in ecosystems, a predator-prey dynamic such as wolves and deer's populations fluctuate as each influences the other, demonstrating how interconnected systems can behave chaotically. Quantum uncertainty versus classical chaos at the quantum level. Inherent uncertainty governs particles like electrons. The more precisely you measure an electron's position, the less you know about its momentum, and vice versa, making future positions. In contrast, Newtonian physics, applied to larger objects, is deterministic, using equations like force equals mass times acceleration to predict motion. Yet, even in Newtonian systems, chaos emerges due to sensitivity to initial conditions, as seen in weather models where tiny data discrepancies lead to wildly divergent outcomes. Historical insights on predictability in the early 19th century. Scientists believed that with enough data, the universe's future could be predicted with certainty. However, by the 1960s, studies in meteorology revealed the limits of this view. A researcher running weather simulations found that minute rounding errors in data inputs caused drastically different forecasts, cementing the butterfly effect as a key concept in chaos theory. This showed that even deterministic systems can be unpredictable in practice. Living with chaos. Understanding chaos theory offers practical insights. A balloon pilot can navigate by exploiting atmospheric dynamics, while recognizing the interconnectedness of ecosystems and economies can guide sustainable decisions. Chaos is inherent in life. Our choices ripple outward, shaping the world in unforeseen ways. Embracing this unpredictability fosters adaptability and creativity, turning us into improvisers in a complex, ever-changing universe. Chaos theory bridges order and disorder, revealing simplicity beneath complexity. It reminds us that while we may not predict every outcome, we can find wonder in the patterns that emerge, connecting us to the broader tapestry of existence.